Now let us understand the irrational numbers. We have already discussed that real numbers has two parts. One is irrational number and other is the rational. All real numbers which are not rational are definitely the irrational number. But we can define it like this. All real numbers which cannot be expressed in the rational form p upon q, where p and q belong to integer and q is a non-zero integer. So that is the definition of irrational numbers, real numbers that cannot be expressed in rational form p upon q. We have discussed pi is an irrational number because the value of pi is 3.1415925 etc etc, and these are non-terminating and non-recurring. You can see there is no recurring part within this, so this is non-recurring. So all decimal numbers which are non-recurring and non-terminating are irrational numbers. There are other numbers like root over m is an irrational number if exact square root of m does not exist. For example, root over 1 is equal to 1, so this is a rational number. Root over 2 is an irrational number, and root over 4 is equal to 2. That means root over 4 has an exact square root, so this is a rational number. Other examples are root over 3. In the decimal form, the value is this much, 1.73205080 etc etc, and this is non-terminating non-recurring decimal. Similarly, root over 2 and root over 5, these are non-terminating and non-recurring decimal, and they do not have any exact square root. For cube root of m is an irrational number if exact cube root of m does not exist. Cube root of 2 is an irrational number. So in the decimal form, you can see cube root of 3 is equal to this one, 1.4422495703 etc etc, is a non-terminating non-recurring decimal. Cube root of 2 is also a non-terminating non-recurring decimal. So in decimal form, all non-terminating non-recurring decimal numbers are irrational numbers. But remember, these numbers can be represented in the number line. So till now we get that rational number is not a subset of irrational numbers, and also irrational number is not a subset of rational numbers, but rational number is pure subset of real number. Also, irrational number is pure subset of real number. And if we consider both rational and irrational number, the union of both rational and irrational number is real number. Combining both rational and irrational, we get the set of real numbers. But if we take the intersection of rational number and irrational numbers, that means common numbers which are rational as well as irrational, there is such number, so this is a null set. So let us represent all the real numbers in a Venn diagram. So we can represent the set of natural numbers by this Venn diagram. So this is set of n, 1 2 3 4 etc. These are the element of natural numbers up to infinity, and if we include 0 with this, then we get the set of whole numbers, natural numbers, along with the number 0. Now again, if we add the negative of natural numbers, -1, -2, -3, -4 etc etc, then we get the set of integers. So this is the set of integers. Now if we add the fractions like 1/3, 1/4, also the negative fraction -half, -1/3, -1/4, -2/5 etc etc, then we get, including the proper fraction, then we will get the set of rational number, which is shown by this rectangular Venn diagram. So you can see all these sets, natural number, whole number, and integers are within this set of rational number, the rectangle. So these are the rational numbers. But in case of irrational numbers, they are completely different from rational numbers, but they are still real numbers. So this will be shown by this rectangle, and numbers like √2, even pi. E is an irrational number that we will discuss later. Then √3, then also cube root of 2, cube root of 3, cube root of 5, etc., etc. These are irrational number q dash. So from this Venn diagram also you can understand that if we take the intersection of q and q dash, there is no common numbers, and this is a null set. And if we combine this rational number and irrational number, then we get the real number. These real numbers are the union of both rational numbers and irrational numbers. So this is all about irrational numbers. In the next part, we'll discuss the number line for irrational numbers, how the numbers √2, √3,